All right, welcome to podcast for our quiz over chapter 5. Just a couple of reminders here about our success guides. First of all, make sure you have that out, follow along. Reminder, you can pause, stop, and rewind this video to go to any part that you'd like to watch. Watch it as many times as you want. Study guide does not have a due date, but of course if you want to do well on the quiz, you should do it. Take the practice quiz over and over and over again. Watch if there are any other videos on My Big Campus, and you got to study with your parents. Make sure you study with your parents. Okay, first off, find the kinetic versus potential energy. We're going to start with energy, and I'm going to go ahead and just put these up, talk about them real briefly, and you can copy them down. Ability to do work or cause change. Power is the rate at which work is done. Work is the transfer of energy from one object to another. When you exert a force on an object, that causes the object to move. So important to understand there. If you're carrying something and it's not moving, you're really not doing work. Kinetic energy is that energy of an object due to its motion, and potential energy is the energy that results from the position or shape. Go ahead and pause it. You can copy these down. Okay, the next one. How are potential and kinetic energy related? Well, as we take a look here at this picture of a baseball and its flight, so we've got the ground here. The ball goes up at the top of its path. The maximum potential energy is at its highest. That potential energy is at the highest at the top. So we talked about this in the classroom. They're kind of opposite. So when it's at its maximum, that means the kinetic is at a minimum. And then as it comes down the other side, you can see over here, you're going to have maximum kinetic is at its most as it's moving down and get to the bottom, just like a roller coaster, and minimum potential energy is going to be at its most at its bottom of the drop. So again, as you look, you can see these are opposites. Kinetic is maximum here, minimum for potential, minimum for kinetic here, maximum for potential. Very important. There's a number of questions, and the short answer also deals with some of what's on here with this one. Gravitational potential energy, just a definition. Potential energy related to an object's height. Explain how energy, work, and power are related. Since the transfer of energy is work, then power is the rate at which energy is transferred. That is the amount of energy transferred in a unit of time. Okay, we switch over to types of energy. Nuclear energy, again, just a lot of definitions here. I'm going to go ahead and let you guys copy these down. Pause this as you need. Some of these are pretty obvious. As you look at nuclear, you can see nucleus in the definition. Thermal, we talk a lot about a heat, but basically that's the total kinetic and potential energy. Electrical is electric charges, electromagnetic energy. Remember that that goes with light. And then mechanical is going to be the form of energy associated with the motion, position, or shape of an object. So again, pause this and go ahead and copy these down. Chemical energy, form of potential energy that's stored in chemical bonds between atoms. Sound, it's got to have a medium. Mechanical energy, it's associated with the motion, position, and shape of an object. So we look at this picture here. A drawn bow possesses mechanical energy in the form of elastic potential energy. And it has energy because of its position and the shape that it's in. If it's not pulled back, then it really doesn't have it. Types of energy. How are all these types of energies related? Well, all forms of energy can be transformed into other forms of energy. So some examples down here. We have sunlight to chemical with a plant, electrical to thermal with a pot boiling. The ice cream cone is going to be chemical. You can't see this, it's off the screen. To riding a bike, which is going to be mechanical. And then chemical is the gasoline that's going to be mechanical for your car. So these are actually very similar. Another example is going to be a cell phone. You've got your iPhone 5S here, and that's going to be electrical to electromagnetic. The electromagnetic is how they actually communicate back and forth. It's another type of an energy wave. And then we've got a match. And a match starts with chemical energy. So before it's lit, it has chemical energy. Once it's lit, it's going to give off two types. It's going to give off thermal. Obviously, you can feel that heat. And then also the electromagnetic, so you can see the light coming from the match. Law of conservation of energy states energy can neither be created nor destroyed. Law of conservation of energy means the total amount of energy is the same before and after any transformation. So there's no energy lost. You can't create it. You can't destroy it. You can't get rid of it. So when that conservation takes place, there's nothing lost. It goes from one to the other. How do you calculate kinetic energy? Here's your formula. Half times mass times speed squared. And then potential. I want to remind you, your textbook has some great examples in there. We did some of those. Open that back up. Take a look at those. And then mechanical energy calculated. Again, this is from the textbook. And we're just adding potential and kinetic together. And this is a great example of how it cannot be created or destroyed. So potential, again, is at its most at the top. Kinetic is at its minimum, just like we talked about. So as you take a look at that, you can see this equals 22. And then this is less potential here and more kinetic, and that also equals 22. So there's no loss and no creation between those two spots. They both equal 22. Just a reminder, these questions are great to do in the book, and your reminders from the beginning. Best of luck.